Please like and share and subscribe my channel if you have not already subscribed. 12 questions were asked from the topic Applications of Derivatives from the chapter Differential Calculus in the JEE Main exam held in January 2024 session. We have already discussed the first 4 questions. We now discuss the next 4 questions. This question has appeared in the JEE Main exam held on 29th January 2024 in the first shift. The given problem is let f of x is equal to 2 power x minus x square, where x belongs to the set of real numbers, if m and n are respectively the number of points at which the curves y is equal to f of x and y is equal to f prime x intersect the x-axis, then the value of m plus n is. Right. Let's now discuss the solution of the problem in detail. We have f of x is equal to 2 power x minus x square, where x belongs to the set of real numbers. And its derivative, f prime x is equal to the derivative of 2 power x with respect to x is 2 power x ln 2 minus 2x. Agreed. Now, given m is the number of points at which the curve y is equal to f of x intersects the x-axis. It intersects the x-axis means y must be 0. Right. So, the number of points at which y is 0, that is f of x is equal to 2 power x minus x square is equal to 0. 2 power x minus x square is equal to 0 will give you 2 power x is equal to x square. This is equal to the number of points x at which 2 power x is equal to x square. In other words, the solutions, the number of solutions of this equation in x. That's what it means. In other words, it can also be thought of as the number of points at which the curves y is equal to 2 power x and y is equal to x square intersect. So the point of intersection or the number of points at which these two curves y is equal to 2 power x and y is equal to x square intersect. Thus, m, the number of points at which the curve y is equal to fx intersects the x-axis, is equal to, the number only equal to, the number of points at which the curves y is equal to 2 power x and y is equal to x square intersect. Right. First of all, you think about y is equal to 2 power x. You might have studied in our plus 2 classes. Y is equal to a power x, where a greater than 0 is an exponential curve, and it will lie in the upper half plane, and the negative real axis is an asymptote for this. And we also know that the exponential curves, grows more faster than any polynomial curves. That is, for example, y is equal to x square is a polynomial curve. So it grows faster. So this goes. These are the two things which you have to bear in mind. And now think of, visualize the curve for 2 power x and x square. The intention is that I do not want to make use of the diagrams. So why? Because not many people draw the correct diagrams. Right. So it may be visualized that the curves y is equal to 2 power x and y is equal to x square intersect at a point, say A, in the second quadrant. And I told you that y is equal to 2 power x is an exponential curve, and 2 greater than 0, and the negative real axis is then asymptote for that. And in the second quadrant, y is equal to x square, that curve is also there, that is decreasing towards the 0. They intersect at a point A. So one point of intersection you can visualize very easily. Right. Observe that, when you substitute x is equal to 2, 2 power x is equal to x square. X is equal to 2, 2 square is equal to 2 square, that is 4. Right. And when you substitute x is equal to 4, 2 power 4 is 4 square. Both sides is 16. That means they intersect. That means y is equal to 2 power x and y is equal to x square intersect at the points 2, 4 and 4, 16. So these are the 2 points. The earlier point A. So number of points of intersection is 3. M is equal to 3. Right. And in fact, the curves are like this. And this is the point in the second quadrant what I am talking about. And that is the A. This is 2, 4 and this is 4, 16. And students will get doubts saying that, so how do you say, sir, these are the only 3? Why not something like 4, something like 5 or something like that? And you can use these facts. That is, note that the exponentiation, that is 2 power x, faster than x square of when x greater than 4. That means when x greater than 4, then this curve grows more faster than this polynomial curve x square. That means you do not find any intersection after 4. And x square is greater than 2 power x for x belongs to 2 to 4. For x belongs to 2 to 4, this x square, that is the polynomial, that curve lies higher above the exponential curve in this interval. And the exponential curve grows faster after 4. So that means here they meet, and there will be some distance between them, and again they meet. So in between 2 to 4 there is no point of intersection, and anyway this side no points of intersection other than A. So you can argue that there will be just 3 only. Now we move on to the discussion of n. M is 3, number of points at which f of x, y is equal to f of x, intersects the x-axis. Now n is the number of points at which the curve y is equal to f prime x intersects the x-axis. You know y prime x is 2 power x ln 2 minus 2x. Again, the same argument is equal to the number of points at which the curves y is equal to 2 power x ln 2 and y is equal to 2x intersect. Again, 2 power x ln 2 is again 2 power x only. 2 power x into ln 2 is exponential curve, and this is a straight line passing through the origin. Right. Now let g of x is equal to 2 power x ln 2 minus 2x. The intention is not to draw the curves, and once my argument is over, then I will show you the curve. Right. Clearly, g of x is differentiable on the whole of R. Right. Both are differentiable functions, and therefore g of x will be continuous there. And g of 0 is ln 2, which is positive. G of 1, 2 ln 2 minus 2. ln 2 is, I think, 0.69. 2 times will be 1.38, something like that. Minus 2, that is negative. Now that means g of 0 and g of 1 have opposite signs. Then use our intermediate value theorem. By intermediate value theorem, there exists some point x belongs to the open interval 0 to 1, such that g of x is equal to 0. That is 2 power x into ln 2 is equal to 2x for some x in the open interval 0 to 1. That means one solution you got. You got one solution. Right. The curves y is equal to 2 power x ln 2 and y is equal to 2x intersects for some x belongs to 0 to 1. Agreed. You can also argue in a similar way at a g of 3 and g of 4 also. Observe that g of 3 is 2 cube into ln 2 minus 2 into 3, which is negative. G of 4 is positive. It's positive. Again, by intermediate value theorem, there exists then the curves y is equal to 2 power x into ln 2 and y is equal to 2x intersects for some x belongs to 3 to 4. Same argument. So in all you got 2 points of intersection, and you have to bear in mind that 2 power x into ln 2 grows faster than this straight line y is equal to 2x. So since both the curves are strictly increasing functions, not only that, 2 power x into ln 2 grows faster than 2x, they intersect at exactly 2 points. You can use this fact, and therefore n is equal to 2. Now I will show you. This is the diagram, and this is your y is equal to 2x straight line, y is equal to 2 power x ln 2, that is the exponential curve. So the number of points of intersection is n is equal to 2. Required to find the value of m plus n, so that is 3 plus 2 is 5. That is, the answer is 5. Right. That is the detailed discussion of the solution of this problem, and this problem will be definitely a tough one for the above average and above average students, because the curves for this 2 power x and x square, how they behave, and especially in the case of m, they will make mistakes. They will normally say m is equal to 2. So that's the only crux of the problem. Otherwise, it is all right. Right. And in the discussion of this problem, I have used only the theoretical approach, and I have not shown you the curves until I get my answer through theory. And once I get my answers through theory, then I have shown you the curves. Agreed. Anyway, let's move to the next problem. This problem has appeared in JEE Main, held on 29 January 2024 in the second shift. The given problem is the function f of x is equal to x by x square minus 6x minus 16. X belongs to R minus the set consisting of minus 2 and 8. X belongs to the set of all real numbers except x is equal to minus 2 and x is equal to 8. And we are given 4 options. These 4 options will tell you, where this function f of x increases, where this function f of x decreases, and so on and so forth. That means you have to discuss the increasing and decreasing nature of this function. Agreed. So we have our function f of x, and that is equal to x by, we have factorized the denominator. We got the factors as x minus 8 into x plus 2, and that is why x is not taking the values of minus 2 and 8, because it is sitting in the denominator. Agreed. And to talk about increasing decreasing nature, we have to first consider the critical points. For that, we take the differential derivative. f prime x is equal to, use the quotient rule for differentiation, u by v, that is numerator by denominator, that is denominator multiplied by the differential of the numerator minus numerator into differential of the denominator by the denominator square. Simplify, you will get minus, is again a quotient, numerator is x square plus 16 by x minus 8 whole square into x plus 2 whole square. And again x minus 8 and x plus 2, they are sitting in the denominator, therefore x not equal to minus 2 and x not equal to 8 we have to consider. And the numerator is x square plus 16 is always positive for every x, and x minus 8 whole square is always positive for any x other than 8. X plus 2 whole square is again positive for any x other than minus 2, because they are squares, because they are positive. So positive by positive is positive, so minus, that is negative. So on the whole it is a negative less than 0 for all x not equal to minus 2 and 8. So now use the first derivative test, that is f prime x is negative for all x other than minus 2 and 8. That means the function f of x decreases on r minus, is a decreasing function in r minus the set consisting of minus 2 and 8. This implies fx decreases in r minus the set consisting of minus 2 and 8 is same as minus infinity to minus 2, open interval, union, open interval minus 2 to 8, union, the open interval 8 to infinity. Minus 2 is not considered and 8 is not considered, the whole real number line. So that is precisely there at the option 4. So therefore the answer to this question is option 4, and that is the detailed discussion of this problem, and it is a very simple, straightforward question. Questions of this type occur once in a while but not always. Let's now move to the next question. This question has appeared in the JEE Main exam held on 30th January 2024 in the first shift. The given problem is the maximum area of a triangle whose one of the vertex at 0, 0 and the other two vertices lie on the curve y is equal to minus 2x square plus 54 at the points ordered pair x comma y, ordered pair minus x comma y, where the ordinate y greater than 0. And we are given 4 options. So we are given a triangle whose one of the vertex is at 0, 0, and we have the other two vertices will lie on the curve y is equal to minus 2x square plus 54 at points x comma y and minus x comma minus y, where y greater than 0. So y is this minus 2x square plus 54, that is the inverted parabola. Now y greater than 0 will imply minus 2x square plus 54 greater than 0. Now minus 2 is common and cancel. Then you will get x square minus 27 less than 0, because you have divided by minus 1 by 2. That is a negative number. Therefore the inequality will be reversed. That will be less than 0. This is the product of two factors, x plus 3 root 3 multiplied by x minus 3 root 3 is less than 0. That will imply x belongs to the open interval minus 3 to 3 root 3 to 3 root 3. Right. And what is our goal? Our goal is to find the maximum area of the triangle. Let A be the area of the triangle. Then A is equal to, given by, because we know the coordinates of 3 vertices. One vertex is 0, 0. and x comma y and minus x comma y. And then we use the determinant formula. That is the mod of 1 by 2 half times the determinant corresponding to the vertex 0, 0. That is 0, 0, 1. That's the first row. Second row is corresponding to second vertex x comma y. That will be x, y, 1. Corresponding to minus x, y, the third row, minus x, y, 1. That will be equal to modulus 1 by 2 into, now expand this determinant by its first row. Then you will get 1 times xy minus of minus xy. Right. That is mod of 1 by 2 times 2xy, 2 cancels, mod xy, that will be equal to mod x into mod y, and y greater than 0, mod y will be just y only. So mod x into y, that is equal to mod x into y is minus 2x square plus 54. By the by, y greater than 0, that means the values of x you have to consider only in this interval to find out the maximum area. Right, let's now continue. We have the area mod x into minus 2x square plus 54. Ax belongs to this open interval and required to find a max. Let's now consider the positive values of x. So let x belongs to 0 to 3 root 3. Positive values we have considered. Right. And suppose we fail to get a max, then we move to the negative values. But we normally get at positive values. Then a is equal to mod x will be x only, because this is x is positive values we have considered. X into minus 2x square plus 54 and multiply minus 2x cube plus 54x to find out the maximum of a of x. A is a function of x. So we go for the first derivative. dA by dx is minus 6x square plus 54. To get a critical point, dA by dx is equal to 0, will give you x square is equal to 9. That will imply x is equal to 3. Why? We are considering positive values, therefore we have taken x is equal to 3 only. And we take d square a by dx square, it will be minus 12x. And d square a by dx square value at x is equal to 3 is minus 12 into 3, that is minus 36, which is negative. Therefore, at this critical point x is equal to 3, the second derivative is negative. Therefore, the area A attains maximum when x is equal to 3. And the maximum value is A max is given by the value of A, the function A at x is equal to 3. And that will be minus 54 plus 162, that is 108. And 108 appears against option 1. Therefore, the answer to this question is option 1. And that is the detailed discussion of this solution, and it is also very simple question. Let's now move to the next question. This question has appeared in the JEE Main exam held on 30th January 2024 in the second shift. The given problem is, let f of x is equal to x plus 3 whole square into x minus 2 whole cube, where x belongs to the closed interval minus 4 to 4. You have to note down this fact that this x is coming from the closed and bounded interval minus 4 to 4. This is very important while considering the maxima and minimum problems. So, the maxima and minima can attain in the case of closed intervals at the endpoints of the interval also. Therefore, you have to take that into account. If capital M and M are the maximum and minimum values of f respectively in the closed and bounded interval minus 4 to 4, then the value of m minus m is, we are given 4 options. Let's now discuss the solution of the problem in detail. We have the given function f of x is equal to x plus 3 whole square into x minus 2 whole cube, where x belongs to the closed and bounded interval minus 4 to 4. To compute the maxima and minima, our first concern is to talk about the critical points. How do we get critical points? Take the first derivative and equate it to 0. So take f of x and take the first derivative. F prime x is equal to the first function x plus 3 whole square into x plus 3 whole square into derivative of the second function, that is 3 into x minus 2 whole square, plus second function x minus 2 whole cube into the derivative of the first function, that is 2 times x plus 3. Now x plus 3 into x minus 2 whole square is common. We have taken the common factor and we have simplified. We got x plus 3 into x minus 2 whole square into 5x plus 5, taken the 5 common. We get x plus 3 into x plus 1 and x minus 2 whole square. The critical points are f prime x is equal to 0 will be x is equal to minus 3, minus 1 and 2. These are the critical points. Agreed. Now there is no need of going into and discussing the local maxima, local minima and all that. Now, because it is a closed and bounded interval, it is given. We consider now m to be the maximum value of f in the closed and bounded interval minus 4 to 4. Then we take the maximum of the values of f at the critical points, that is minus 3, minus 1 and 2, and at the end points the values of f at the end points, f of minus 4 and 4. Take the maximum, then you will get the maximum value of f in the closed interval minus 4 to 4. Closed interval minus 4 to 4. This is in other words, we call it global maximum. Yeah. But in the closed interval, it is given the maxima and minima cannot attain at the endpoints also. Therefore, we consider this. Now, look at this snippet. The value of f of minus 4 for in f of x, x is equal to minus 4 is substituted and simplified. Minus 216. F of minus 3 is 0. X plus 3 is there. X is equal to minus 3. This will be 0. X is equal to minus 1. Substitute. You will get minus 108. F of 2, that is 2 minus 2, that is 0. And f of 4, the other extreme point, that is 392. Take these points, take these values and substitute here. Maximum of minus 216, 0, minus 108, comma 0, comma 392. The maximum of all of them is 392. M, small m. The minimum value of f in the closed interval minus 4 to 4 is the minimum of the same values, and substitute them. In these, what is the minimum? The minimum is not minus 108, it is minus 216. So m is 300, capital M is 392, small m is minus 218, and required to find the value of m minus m, that is 392 minus of minus 216, that is 392 plus 216, that is 608. This answer 608 appears against option 1. Therefore, the answer to this question is option 1. And that is the detailed discussion of the solution of this problem. And it is also a simple problem. But you have to remember there is a closed interval. The maximums can occur. Maximum and minima can occur even at the endpoints of the closed interval. That you have to take into account. So, I am sure that you have understood the problems, the 4 problems that I have mentioned here and their solutions. Please like, share my videos and subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.